Hey guys, welcome back to the shop. So we're going to carry on and try to get our pipe flanges finished today. And in the previous video, you might have seen that we did all of our lathe work on these rough cut blanks here, where we had to turn the OD, bore the ID, face them to the right length. And on today's video, we're going to be working on getting our hole pattern drilled. This is a 4-hole pattern, and the holes that they have specified for these flanges are drilled 20 millimeter. They just need a simple hole drilled in it, and that's going to be a clearance hole for a 3/4 inch bolt to go through these flanges. So we're not going to be worried about milling them to leave any kind of specific finish or an exact diameter on that. We're just going to go with a 20 millimeter drill. And I do have my drill that I ordered. We got it right here. So I absolutely love the Trim Meister drills from Alloy. I've shown them in the past. We've done other jobs using that. And I went ahead and got a 20 millimeter size here to do this job. And of course, it'll be helpful for any jobs down the road. We got the insert for it right here. So this is a carbide tipped drill where you install the insert, and then we'll put this in a collet chuck. I ordered some sealed collets, and this particular drill needs a 1-inch collet. I didn't have a sealed, so I got that on order, and it should be here today anytime. I'm kind of waiting for UPS to drop those off, and then once those get here, we'll be able to set up our tool. But what we're going to start on to begin with is the setup with our vise. And the approach that I decided to take with our flanges is I'm going to machine some soft jaws using a standard 6-inch milling vise. And the reason why I want to go this route is, for one, that's going to keep from putting any kind of marring or imperfections on the OD of this, because I do have some other ways that I could clamp it using some other jaws, but I'm afraid that it's going to leave some marks on there by pinching it, and I just really don't want to do that to these flanges. So I think the best approach is going to be my aluminum soft jaws. I've got plenty of these aluminum soft jaws for Monster, and we're going to take this one right here and get it set up and machine it, so that what we can do is just have our radius machine. So basically have a radius pocket on both of those jaws there, where we can just simply set our flanges down there like that and clamp it and do our drilling. The other reason why I wanted to go this route is that there's a possibility that the customer may be ordering more of these down the road. So instead of just having a simple setup where we would traditionally go to the milling machine here and just clamp it down, because that's the other good way to do it. You can just set it like that and put some strap clamps on it, but then you got to indicate each one, and I don't want to do that. I just want to use a milling vise, and we're going to have the soft jaws machine. I'm actually going to engrave on here for these particular pipe flanges, so that when we get an order for these in the future, I already have these ready to go, and we can just mount them up in the machine, and then we can clamp our flanges without putting any marks on the OD. So we're going to go over to the VM. I need to take one of our Tool-X vises off. I'm going to put one of our standard Tico vises over there, get our soft jaws mounted, and the first thing we'll do is go ahead and machine a set of these soft jaws to hold our flanges and get that part of it done, and we can get it all set up. And hopefully sometime this afternoon, our seal collet will come in, and we can go ahead and work on getting our tools installed in the machine as well. So we'll head over to the VM and start getting it set up. I just finished running our purple drill indexes, so our setups here for that is complete. So what I'm going to do is I'm going to remove this right side vise and get it off the machine, and we'll use the right side of the table and get a standard milling machine vise set up in here. I have absolutely loved these new Tool-X vises, and they have been working excellent for our drill index production. You got these, we run the 4140 jaws that are reversible, and so I would like to look into maybe getting a couple more sets of soft jaws for these vises here. You can get them in aluminum as well, and be able to keep the vices mounted on the machine and just take these jaws off and put different sets of soft jaws on there. But I've got a drawer full of those monster jaws that I bought a while back. They're pretty inexpensive, and we got plenty of milling vices, so we're just going to go that route for now. I got to go find my tools to crack that thing loose. But I'm learning I'm learning all the time. I'm trying to learn as much as I can. I get, you know, inspiration from seeing other people, you know, especially Instagram and Facebook, and just seeing what other people do, what kind of work holding techniques are being used. So it's always something to learn and improve and build upon. I think something else that would greatly benefit me is if I would invest the time into making maybe some sort of subplate for these vises too, so that we can just set them down on the table and just bolt them straight down and do away with these clamps like this. I do put these aluminum shims underneath the heel of the clamp there just to keep from marking up our fixture plate. And I'll be interested to see what the bottom of the vise looks like again, because I always, anytime I'm setting up any kind of vise or fixture, it's going to be bolted down for a little while, I spray it with my CRC SP350 rust inhibitor, and it seems to be working really well. I've been using that on our CNC mills for a few years, and it's always done a good job. And we're going to do the same today as well. So let's see if it slides. Yep. And you can still see we got a little bit of coolant underneath there. And that SP350 is keeping this bare cast iron here from rusting. You can see they've been on there for a little while, so we got some nasty coolant there underneath it, but we'll wipe that up. And I'm going to set these over on our cart, and I'm going to go ahead and clean the bottom of this and retreat it as well. All right, our table is looking good. Before we put our vise on, we'll spray it down. Now here's the bottom of our Tool-X vise. So this has been bolted down for a couple of months now. I don't know exactly, but a couple of months it's been pulled down. And it looks good. It looks fine. Just trying to get some of this coolant mopped up on it. All right, and then this is our rust inhibitor we love running, the SP350. Just give it a good coating. And then we'll use this over on the table as well before we get our other vise mounted up. I'll probably just grab this one right here. And I wanted to show you, so you might be able to tell, that's actually SP350 sprayed on this one whenever I set it on here. I don't know, this has been over here for a few months. And we pull this back a little bit, and you can see how the coating that you spray on there, it dries somewhat. Some of the moisture evaporates out of it, and it leaves sort of a waxy, oily type surface. You can see it a little more right there. And what this is going to do for long term, it's just going to protect all those bare metal surfaces and keep it from flash rusting. A lot of people deal with moisture in the shops, and that's what's going to cause rusting on all your bare metal tools. So if you use the SP350 like this, it will protect all of your high quality tools from rusting over and keep them looking good. When you're ready to use your tool, you just simply get you a rag and wipe the stuff off. And you can easily break it apart if you use some power lube on it or some of their other penetrants and lubricants. You can use that to kind of break up the SP350 and get it off there a little bit easier. But you can see how nice it is to help keep all of these pretty ground finishes from rusting up while it's just sitting there. Same thing with the back of the jaws, the jaw faces there. put a little bit of that on there too whenever you bolt them together, and it'll keep that nice little layer of lubricant between them and help prevent any rusting. All right, so this is some of the soft jaws that I keep in stock, or I bought some to keep in stock here. Monster makes these in a variety of different sizes and even steel versions as well, and they're pretty inexpensive. You'd be surprised at how inexpensive these are when you compare them to, you know, buying a piece of stock and then doing all of the machining on them yourself. And you can certainly do that, and I know a lot of people do, but it's convenient to have them in the drawer ready to go. And they are fully machined. Fully machined soft jaws on all sides. Go ahead and make sure all the dust is off everything. And are these bolts going to work? I can't remember. Oh yeah, those are going to work just fine right there. The other way. I'll torque them a little bit more once we get the vise bolted down. Okay, I think we're just about ready to go on the mill with it. I'd like to make sure the bottom is good and clean, so let's do that next. Just get any of the oil off, and then I'm going to grab my stones. Usually doesn't take much. In case you put a scratch or two in it the last time you used it, that's kind of what we're doing here, is just make sure to remove any of those scratches using our precision flat stones there. All right, let's get a coating of our SP350. All right, now we're ready to go to the mill. I'm going to go ahead and put some plugs in our 4-hole locations for our Tool-X vises. All right, let's just make sure it is clean again one more time. There's a bush or a plug right there that it keeps hitting. All right, good. Now we'll go in here with our SP350. And I'll grab the vise and bring it in. On these particular vises here, what I find to be most helpful is if you line up the hex here for our wrench back away from the edge of the table, because I've learned that when you set them on there, you're not really paying attention to that. You get it clamped down and you realize the hex is kind of overstepping the side of the table there. So just kind of bring it back so that the hex or the end of this vise is just kind of flush with the table. That looks pretty good right there. We'll go ahead and I just use one of these picks and pick the 2 plugs out. All right, I got to find me some bolts, clamp this down. Allen socket head bolts with the heavy duty washers. That's what I buy these from Tico as well. They make them in all different sizes. Now, before I tighten it down, we'll go ahead and tram it and get it nice and square. I'm gonna install this keyless chuck. That's really, the only thing I really use that for, honestly, is to hold my indicators. So this is an indicator that I've already got kind of set up in this Noga holder here. We'll be able to use this to easily indicate this Vise tram. Going to use our pendant here to control our movements. See if we got it straight. We did not get it straight at all. About 3 thou. 1. That's it right there. Got a few tenths movement. It's actually, it goes deeper a little bit in the center of the jaw right there, just from the machining of it. All right, so that's going to be good right there. I'm going to go ahead and get our wrench and lock our bolts down. I'm going to retorque those. I just want to make sure we didn't move it. Yeah, that's beautiful right there. All right, so let's take it back up. All right, guys, I'm going to give you a quick simulation in our Fusion software and show you what it's going to look like machining our 2 parts. So we have our pipe flange and our jaws here, and I created these in sort of reversed order because this was a part that I quoted quite a while back. In fact, it was actually last year that I quoted these, and I even machined a sample on my own just because I wanted to kind of prove it out. But it's taken this long for the end customer to approve the entire job, and then once they did, I got the order for machining the flanges here. So that's where we are. We got the pipe flanges, and then I have the soft jaws here that we're going to be machining. So we'll go ahead and just activate our soft jaws. And keep in mind when we simulate this, all the center and in between the jaws are going to be blue, but just know that it's just air. There's nothing in here. The Fusion just thinks that this is a solid piece of aluminum just because of the way I modeled it up. But if we go to our simulation, we're going to use a 1/2 inch 3-flute helical end mill to do our 2D adaptive and 2D contour. And that's just going to be on both of these jaws here. Remember, this is all just air out here, so it's not going to crash. So 2D adaptive to rough out both of the pockets. And once it gets this pocket roughed, it's going to come back for a contour pass, 10 thousandths to clean up that wall. And it's going to jump over to the other jaw, rough it out with another 2D adaptive tool path. And then I left 10 thousandths on the wall to make that finished pass. And then it's going to, there's the contour. All right, and then I've got a 1/4 inch chamfer tool that we're going to use to chamfer both the top and bottom edges just to break those sharp edges off. And then the last thing is I got a trace program. We went ahead and put some text on here that says pipe flange is 7-inch OD, just to help me identify what these jaws are whenever they go into the toolbox. I've already got a few sets of soft jaws in there, and I know that this is something that a lot of folks like to do to help identify these, so I'm gonna try to start using that same practice as well and just putting a little bit of data on here, because you can use a Sharpie, of course, but that can rub off, so I think it's just a little classier to go ahead and engrave something on here so you know exactly what those jaws are. So anyway, that's the soft jaws. Now we'll come up here to our drill pipe flanges. And there's 2 tools we're using. 20mm drill, and then we're going to be using that same 1/4 inch chamfer mill to chamfer the top edge. I will say that I'm not going to be chamfering the bottom. That's something that I still need to get on with. You know, I need to get me a couple lollipop mills in here and practice doing a bottom chamfer, where if I shift and rotate this around, having a lollipop mill will allow me to come in here and break these bottom edges too. So it's just something that I need to continue striving to get to and make that happen in our machine work around here. But let's go ahead and simulate this one as well. This is going to be our 20mm Trim Meister drill, and we're just doing a straight through drill all the way through using coolant through the drill. All right, coolant through spindle. Just going to pop those in there quick and easy. It'll take less than 30 seconds to drill all 4 of those holes. Then it's going to grab the 1/4" chamfer mill and just do a chamfer on the top side. And my plan is, once I get through with all 4 of these flanges, I'm going to set them up in either the mill or the Flexarm and chamfer the bottom side manually. And so that's it right there. That's all it is to it. So let's go back out to the mill and get our soft jaws machine. All right, one of the things I forgot to mention to you whenever we machine the soft jaws is that I've got this spacing in here set to 5 inches. And what I'm going to do to space that is I'm going to use my Starrett 706 blocks. These are precision ground 1, 2, 3 blocks. I've used them for many setups in the machines, and they're going to work great for this right here. The end mill is not going to come down and hit that, because we're only going down 1/2 inch, which is above these pockets here where the bolts go in. You know what I should have done before I set them in there? I should have wiped them out. Let me get one of my rags here. Make sure that the bottom is wiped good. So that'll give us a 5-inch spacing right there, the 2-inch width and the 3-inch width. And I've got 2 pairs of those, so I'm going to grab the other ones out of my drawer here. That looks good. Tighten up our vise. Okay, and we're ready to mill those. The other thing I forgot to mention to you is the work offset. On our soft jaws, I actually have it set on this upper left corner. So we're going to find this corner, and then that will actually move to the center of the jaws there. And then whenever we go in with our pipe flanges and machine, once I get the first one in there, I'm going to probe the center bore of the pipe flanges themselves, and then that will be our work offset whenever we're drilling the holes. But just for the soft jaws, we're going to work off this back corner right here. Let's go ahead and get our end mill installed. Take this chuck out. So this is the end mill we're going to use to mill our pockets. This is a 3-flute helical end mill installed in a Technic shrink fit holder, and I borrowed this from the TRM. It's already set up ready to go, so we're just going to use it. We'll get our tool probe called up. All right, let's make some chips. I always put the cutter down there close to where I'm going to cut so I can get the camera framed. It'll come back up when we start the program. And as usual, I'm going to bring it down nice and slow and make sure that it's at the proper depth. It should be, but I'd just like to be sure. This is a one and done program, so I'm going to try to do it without any air cuts. All right, bring the rapid down nice and gentle. I am going to be running flood coolant, so I know it's going to get on the camera, and I apologize, but we got to do it. Oh yeah, see, this is wrong. I'm going to halt this. I'm going to halt the program. So you guys some of you probably already know what I did wrong here. Cutter's in the wrong position, right? As far as the Z, when I had the probe out, I forgot to touch off. This is supposed to be our Z0 right here, the top of the jaw, and all I did was the corner. Forgot to touch off on Z. So I'm going to just do that really quick off camera, get the probe, touch this. This will be our Z0, and then we'll get back to this right here. Turn this coolant off. That looks good. We did not crash in our 1, 2, 3 block there. I think we're going to be good to go. I'm going to do coolant and send it. Well, that sounds beautiful. Contour pass. You guys are getting flooded with coolant. Contour pass. All right, tool change to our chamfering mill. Same thing. Let's come down nice and gentle with this. Make sure we're in a good spot. I believe we are. Chamfering that lower corner. All right, now we got some engraving that we're going to be doing here. I'm just halting this where we're at. I want to blow that coolant off. I'm going to engrave this without any coolant. That's how I do my drill indexes. It looks beautiful. That was a really nice cut with that end mill. We got a really nice finish in there too. All right, so let's see if we've got our tool length correct for our engraving. Go ahead and hit resume. I think we're good. It's hard for me to see it back here behind the window, but I can see some chips. I think we're cutting. I've got that set at -2 thousandths on the depth using a 1/16 3-flute ball end mill. If it doesn't seem deep enough, I'll just recut that again with a little bit of depth adjusted. Oh, that looks awesome. Yeah, it's perfect. I'll get you guys a closer video so y'all can see that. That looks awesome. It was really hard to tell standing out the machine if that was deep enough, but yeah, it's definitely deep enough. You can definitely see what's on there. Very cool. Real happy with the success of this simple little milling program. Very rewarding. I'm going to go ahead and get our sterret blocks out of here. I want to get these guys cleaned off, get this coolant off of them, and put them back in their cases. But before I do that, real quickly, let's go ahead and grab a flange and stick it in there and see if it lines up the way it's supposed to. Beautiful. Love it. That's a nice touch on there with the text that we engraved. Really like that. So I'm really happy I went this route because, as I mentioned, this could be something that I do again in the future, and when I do, we're this far ahead on this. So I'm investing some of my personal time and some of this, a little bit what I'm showing you doing, but this is just going to help me out in the long run if we get some more of these things to machine in here. So this is ready to go. What I need to do now is go ahead and get our drill set up and get that in the machine, get it touched off, and then we can move on to drilling our holes. Let's take a look at our new Trim Meister drill. That's going to be the install tool for the insert right there. Got the 2 holes going all the way through there to come out right on the tip of the insert. And then this is going to be our actual insert right here. That's our 20mm carbide insert. So we'll go ahead and get these two and mated together. So my collets came in today. I told you I ordered some sealed collets from Haas Tooling. This is the second time that I've ordered from them. So I had kind of recently learned about their, I believe it's the Haas Winner Circle website. My buddy Kevin was telling me about that, where they have all kinds of tooling, and I've been seeing them advertise just about everything on Instagram over the past year or so. But he told me that if you sign up with the Winning Circle program from Haas, I believe it's $100 a year, you get free next day shipping on all their tools. So I did that because they were having a promotion one day for 10 bucks for that membership. So I went ahead and got it, paid 10 bucks for it. There was a specific drill that I needed for a job that I could not share. It was a NDA job that I did, but I needed a specific size carbide drill, and they had it in stock, and I ordered it, and it was here the next day, UPS. So I went ahead and got these collets. I ordered them yesterday as well, and the collets were actually on sale. I guess they were having a 4th of July sale or something. I'm not sure. But anyway, I went ahead and just got from 1/2 inch up to 1 inch and a sealed collet style. I have never gotten anything from Haas before other than that one drill that I'd said I ordered. So I don't know who they have making these collets. I don't know where they're coming from or anything. But if Haas is selling them, I've got to assume that they're pretty good quality. So this is an ER40 1 inch sealed collet. for our new tongue alloy drill. Well, it fits in there just beautiful. Look at that. Nice fit. All right, so we'll go get a holder and get this guy clamped in there, and then we'll get our carbide insert installed. Okay, we've got our new drill installed, touched off. So the last thing we need to do before we can start drilling is go ahead and call up our probe, and let's go ahead and find the center of the bore. And then our Z location is going to be right off this face here. So this is Z0, and then the bore is going to be our XY0. Okay, we've got our workpiece located on our correct work offset. I want to test that CTS before we start anything there and just kind of see what it's going to look like. This guy right here. Well, I definitely do not see a sealed collet, if you will, but we definitely got a lot of pressure coming down through the drill there. It's still coming through the collet a little bit as well, but that's all right. When I was testing the CTS, I noticed that the coolant level was getting a little bit low. I definitely don't want to cause any damage to my pump there, so I'm just making sure that it's topped off well. So we got our Microsol 685 going in there, just topping it off. I've been doing some checks, making sure my clearances and my heights look like they're correct, and I believe they are. So I'm ready to make some chips. So I'm gonna go ahead and hit cycle start on this program, and let's see what happens. I apologize about the coolant. Once again, it's gonna splash on the camera, but I'm gonna try to get you the best video I can. I got you mounted inside the machine, but with this CTS and a little bit of coolant spraying out of the nut there, it's probably gonna get on the camera, but I'm gonna do the best I can. All right, here we go. Let me get the program fired up again. Beautiful. No problems at all. Switching over to our chamfer tool, we're going to chamfer those 4 holes. Awesome. I am really happy with that. We had no issues and it seemed like our drill worked perfect. Nice looking chamfer on there. I think everything is good. Take a look at that, that surface finish in there. I mean, the surface finish looks good for a drilled hole. So I'm really impressed. Those Drill Meister drills always do such a great job. I'm real happy with that, real happy with it. A couple of things I believe I failed to mention to you guys. Our bolt circle diameter is 5.5 inches. And on our drill, I set it at 325 surface feet a minute, which is on the low side of what those drills can handle. And feet per tooth, I've got it set at 10 thousandths feet per tooth, and that again is on the low side. I believe they even recommended starting around 12 thousandths per tooth. So we have quite a bit that we could improve on drilling these holes if I really wanted to, but we've got 3 more of these to drill. So we're not really concerned about how much time we're spending on it, because we've got more time in just our setup and soft jaws than just drilling the holes. But if we had quite a few of these to do, if I was running a nice production run on these, I would definitely start increasing the chip load on these to try to maximize, you know, or make our time a little bit more efficient drilling these holes. But for doing 4 of these, we can't complain about that. Just taking a look at the back side there. That looks great. We'll just do a manual chamfer on this back side here and knock those out. Well, let's grab the next flange and keep going. All right, that's flange number 3 finished. All right, this was flange number 4. So all of our hole making is now complete on the Miltronics. Here's the other 3 here. So the last phase of our machining is we just need to deburr the back side of these guys. I may just set up my little Flexarm here hooked to the Kaiser and just deburr it right there. I was either going to be there or the milling machine, but I got some vises over on the mill, so we may just use the Flexarm for that there. I need to get all this mess cleaned up. This is all from turning them over here on the pacemaker. That definitely got a messy shop that I need to start getting cleaned up. But anyway, just real happy with the results here. Real happy with our Trim Meister drill from Tungalloy. These things work so well. I'd really suggest you give these things a try if you have not used one of those yet, and give it a shot over here on your CNC mill, because I have a feeling you'll love them just as much as I do. Just really happy with the hole making that they provide. All right, so I decided to use the pneumatic Flexarm to do our deburring there. We've got our Kaiser compressor hooked to it, and it should work pretty good. I got a 90-degree, basically a countersinking tool in there, but that's the 6 flute cutter. I'm just getting these guys off out of the way, and we'll see how it does. It really just needs just a quick spot. I'm using low gear. Yeah, perfect. Yeah, beautiful. Got rid of that sharp edge there, broke the edge. Probably got about a 10th thou chamfer break on there. That worked good. We'll go ahead and get the other 3 done now. Done. D-U-N, done. All right, guys, well, that's going to wrap up this job. Everything is complete. I'm real happy with the outcome there. Everything looks good. We've got some nice finishes on it. Dimensionally, everything is right on size, just the way they wanted it. Just couldn't be happier with the outcome. And I'm really happy with the performance of our 20mm Trim Meister drill. These things always work great. The Miltronics handled it great. And I don't remember if I mentioned it earlier in the video, but I was watching the spindle load meter whenever this was drilling, and it was right around 32 to 33% on the load. So I know that I could kick this up and feed it harder if we wanted to. And if I had more of these to drill, I would definitely do that and kind of reduce that cycle time. But these work really good around the 300 to 325 surface feet per minute, and starting at about 10 thousandths chip load per tooth, and then go up from there. Just kind of see how your machine handles it. But this one worked really good. Absolutely love it. I've got several of these Trim Meister drills from Tungalloy. If you haven't given them a try, I would highly recommend to give it a shot for your production. Everything I've got from them, the face mills, all of the different inserts that I've used, and these insertable drills have been high quality tools from Tungalloy. So super happy with the cutting tools from them. And I think the customer is going to be happy with their pipe flanges there, and I'm sure they're ready to get their hands on them. So we're going to wrap this up and give them a call, let them know they can come and get them. I hope you guys have enjoyed the videos of machining these guys, from the lathe work to the CNC mill, and I enjoyed sharing it with you. And I hope you come back for the next project, all right? We'll see you then.